95% of developers learning AI right now will never ship a single model, not because they are not smart enough, because they started in the wrong place. Total waste of time. I have not used a single eigenvalue since, not one. Over 80% of developers are using or planning to use AI right now. Most of them are wasting time on the wrong things first. I know because I did. There is one skill most AI roadmaps leave out completely. It is the one that actually gets you hired. We will come back to it. There is one resource that changed everything for me, completely rewired how I approach AI. We will get to it. I am a senior front-end engineer. 12 years of React and TypeScript. 6 months ago, I decided to build a production AI system in Python, a language I barely touched. This is the roadmap I wish I had: what to learn, what to skip entirely, and the order that actually matters. Month 1. I did what every engineer does. I opened Andrew Ng's machine learning course. 4.8 million people enrolled. Sounds like the right move. 2 weeks into gradient descent derivations, and I had built exactly nothing. 0 lines of working code. Just notebook after notebook of math. I could not connect to anything real. I have seen this pattern often. I once sat across from a developer, let's name him Alex, who meticulously completed every AI course, earning certificates for advanced topics. He could explain complex architectures, but when asked to build a simple sentiment analysis tool, he was completely lost. All theory, no practical muscle memory. I have seen this pattern many times. A brilliant engineer, let us call her Sarah, spent months studying every ML algorithm. She could explain backpropagation in detail, but integrating an LLM into a simple app left her frozen. The chasm between theory and application was immense. Then I tried reading papers. Attention is all you need. The original Transformer paper. I understood maybe 30% of it. Nobody tells you this. For production AI work, high school math is usually sufficient. The deep math matters for research, not for building. 84% of developers now use AI tools. The vast majority use them through APIs, not by training custom models, not by deriving loss functions on a whiteboard. Remember what I said about AI technology? Here is what I mean. Most explanations start with theory, but for practical application, understanding how to use APIs is far more critical than understanding how they work internally. So what should you learn first? Not math, not theory. APIs. The Claude API. The Gemini API, the OpenAI API. Learn to talk to models before you learn how they work. Prompt engineering is not a buzzword you can dismiss. Demand for it is surging, with companies actively hiring for the role. It is the interface layer between your intent and the model's capability. Understand tokens, understand context windows, understand why a 200,000 token window does not mean you should dump your entire codebase into it. Week 3. I scrapped the courses. I called the Claude API. As a colleague said, the only code that matters is the code that ships and solves a real problem. It worked. That ugly script taught me more about AI in 1 afternoon than 2 weeks of gradient descent ever did. Build first. Understand later. By month 2, I was building my video pipeline. 32 Python files, 6 AI services. I did not understand how transformers worked internally. I did not need to. The biggest mistake I made during this build cost me 2 full weeks. And it was not a technical mistake. Keep that in mind. The build-first approach works because it flips the learning loop. You hit a wall, you research just enough to solve it, you move on. As one seasoned engineer told me, you don't learn to swim by reading a book. You learn by jumping in and figuring out how to stay afloat. Every concept arrives exactly when you need it. MOOC completion rates average 5 to 15%. Many new developers get stuck in tutorial hell. Watching courses is not learning. Building is learning. I built my entire pipeline before understanding backpropagation. And that was the right call. You do not need to understand combustion to drive a car. You need to understand the controls. Now, after month 3, theory starts to matter. But not all theory. 20% of ML concepts give you 80% of the practical value. Embeddings. Understand how text becomes numbers. This one concept unlocks semantic search, recommendation systems, and RAG. It is foundational to modern AI applications. Attention mechanisms. Not the math. The intuition. How a model decides which words matter most when reading your prompt. That understanding changes how you write prompts. Fine-tuning concepts. Not how to train from scratch. Just enough to know when a base model is not enough and what your options are. LoRa. QLORA. Adapters. RAG. Retrieval Augmented Generation. This is not optional anymore. Enterprises increasingly rely on it for their production AI deployments. Learn it early. That is it. 4 concepts. Embeddings, attention, fine-tuning, RAG. Master those, and you can build 90% of what companies are actually shipping right now. What surprised me most? Half the skills I needed for AI I already had. I just did not know they transferred. Pipeline thinking. Your CI/CD pipeline is a training pipeline. Same structure. Automated, reproducible, testable. If you have built a deploy pipeline, you already think in MLOps patterns. Caching, idempotency, cost monitoring. I built hash-based cache invalidation into my pipeline. Same pattern I have used in React apps for years. Memoization is memoization. Your useState is model weights. Your render function is a forward pass. Your useEffect is a training loop. The mental models transfer directly if you let them. The MLOPs market is worth over $2 billion right now, growing at 40% per year. If you know DevOps, you are closer to MLOPs than you realize. Now the resources. I am not going to give you a list of 20 courses. I am going to give you 3, ranked by what actually moved the needle for me. Number 3. Andrew Ng's courses on Deep Learning A. I have millions of learners. The short courses on RAG and LangChain are excellent. Skip the full machine learning specialization unless you want the theory. Number 2. Andre Karpathy's YouTube channel has over 1 million subscribers. His Neural Networks Zero to Hero series builds intuition like nothing else. You feel how models think. And number 1. The resource that changed everything. Fast AI. Most online courses finish at 5 to 15%. Fast AI blows past that. Fast AI teaches top-down. You build a working image classifier on day 1. Then you peel back the layers. It is the build-first philosophy turned into a curriculum, perfect for engineers. Papers. Do not read them until month 4 at the earliest. They are written for researchers, not for practitioners. You will get more from a Karpathy video than from reading Attention is All You Need cold. Remember that 2-week mistake I mentioned? It was not a technical error. It was a learning strategy error. I tried to understand every AI service before using it. I read the entire Gemini documentation before making a single API call. I studied Google Cloud TT's architecture before generating one audio file. 2 weeks of reading. 0 output. The fix was embarrassingly simple. Call the API, read the error, fix it, call again. I learned more in 1 day of errors than in 2 weeks of documentation. Remember the skill most roadmaps skip? Here it is, the most in-demand AI skills for engineers in 2026. Not what LinkedIn influencers tell you. What the hiring data shows. Deep Learning Fundamentals, LLM Fine-Tuning, MLOPs. These 3 sit at the top of every hiring survey. Roles blending cloud and ML start at $140,000. AI job postings significantly increased last year. AI skills are now appearing in a growing share of all job listings, up from 5% the year before. Gartner predicts 80% of engineers will need to upskill to work alongside AI tools, not replace them. Work alongside them. That is a different skill set entirely. My next 6 months. The roadmap going forward. I am moving into the DevOps AI intersection, the part nobody covers. Terraform for ML infrastructure. Docker for model serving. Kubernetes for scaling inference endpoints. These are not ML skills. They are engineering skills applied to ML problems. 87% of large enterprises have implemented AI, and scalable model deployment is a top priority. Someone has to build that infrastructure. It does not have to be an ML engineer. The engineer who can deploy a model reliably is as valuable as the one who trained it. Maybe more. Training happens once. Deployment happens every day. So here is the roadmap. Condensed. No filler. Month 1. APIs and prompt engineering. Build something ugly that works. Do not open a textbook. Month 2 and 3. Build a real project. Multi-file, multi-service. Hit every wall you can. That is the curriculum. Month 4. Now learn theory, embeddings, attention, fine-tuning, RAG. Do Karpathy's 0 to Hero. Do the fast AI course. Theory lands differently when you have built something. Month 5 and 6. Specialize. Pick the intersection of AI and your existing domain. For me, that is MLOPs. For you, it might be AI plus product, or AI plus security, or AI plus data engineering. After month 6, now read papers. Now go deep on the math if you want to, because now you have the context to understand why it matters. The theory sticks when it has something to stick to. The senior engineer advantage is real. You already know how to debug, how to architect systems, how to ship. You do not need to start from zero. You need to start from where you already are. Model API spending doubled last year, from $3.5 billion to $8.4 billion. The market is screaming for engineers who can build with these tools, not researchers who can build the tools themselves. Stop studying. Start building. Learn the theory after you have something real to attach it to. The roadmap is not complicated. The discipline to follow it is. If this roadmap saved you from my mistakes, subscribe. We break down every major AI development so you are never caught off guard. See you in the next one.